Hello students, today we are going to talk about solving systems of linear inequalities. Don't forget as the video goes on to take notes and then do the survey at the end of the video. When we're graphing linear inequalities, we're going to do this the same way we did it before, where we're going to start at the y-intercept. So for example, on the orange one, y is greater than or equal to 2x minus 3. We're going to start at negative 3 and then go up 2 over 1. This is a solid line because it's greater than or equal to. Next thing we're going to do is our shading. I'm going to pick the test point of 0, 0. If we put 0 in for x and 0 in for y, 2 times 0 is 0. 0 minus 3 is negative 3. Is 0 greater than negative 3? That is true, so we're going to shade where 0, 0 is, which is above the line. Our next equation, we're going to start at positive 2 and go up 1 over 1. Up 1 over 2. It is a dashed line because it's just less than. Again, I'm going to pick a test point of 0, 0. If I put 0 in for x, 0 in for y, 1/2 times 0 is 0, plus 2 is 2. 0 is less than 2. This is also true, so we're going to shade where 0, 0 is, which is below the line. Now, as you can see here that we have two equations on one graph, and we have lots of shading going on. There's different points that we can pick that satisfy one of the equations, both of the equations, or neither of the equations. So we're going to look at a couple examples. If we plot 2, 3 on the graph, we go over 2 and up 3, we land right there on that dashed line. So if we look at equation number 1, it is in the orange shading, so it does satisfy equation number 1. If we look at equation number 2, it's on a dashed line. Now, we talked about before that if it lands on a dashed line, it is not a solution. So this one's only going to satisfy equation number 1. If we look at 4, 5, we go over 4 and up 5, we're up there at the very top. This is on equation number 1. It's a solid line, so it does satisfy equation number 1. It is not in shading number 2, so it does not satisfy equation number 2. So this one again is only going to satisfy equation number 1. If we graph our third line, point, go up over 4, up 3. We're in the blue shaded area, so it does satisfy the second equation, but we're not in the orange shaded area, so it does not satisfy the first equation. So it's just equation number 2. If we plot one more point, negative 1, 0, we see that it is in both shadings, blue and orange, so this one is actually going to satisfy both of our equations. Now if you take a look at the rest of these points, you'll start to see a pattern. If it just lands in the orange shaded area, then it's just satisfying equation number 1. If it just lands in the blue shaded area, then it's just satisfying equation number 2. If it lands in both shaded areas, then it's satisfying both of the equations. And up there at the very top, it's landing in neither shaded area, so it's not going to satisfy either equation. The B's are what we're looking for here. That's our true solution to the system. Alright, let's try another one. We're going to graph our orange equation again. We're going to start at negative 1 and go up 2 over 1. It's a solid line. If we pick a test point, put 0, 0 in for x, and solve, we're going to get 0 is greater than or equal to negative 1, which is true, so we're going to shade above where 0, 0 is. We're going to graph our second equation at positive 3, go down 1 and over 1. It's a dashed line because it's just greater than. Again, if we pick our test point 0, 0, we're going to put 0 in for x and 0 in for y and solve, and we got 0 is greater than 3. This is not true, so we don't want to shade where 0, 0 is, so we want to shade above the line. Now, we can see on this one, if we just want to satisfy equation number 1, then we're going to land somewhere over here in the orange shaded area only. If we just want to satisfy equation number 2, we're going to land somewhere in the blue shaded area. If we want to satisfy both equations, which is our solution, we're going to land up here in the both shaded area, not on the dashed line though, just on the solid line. And if we want to satisfy neither equation, we're going to land in the blank area with no shading. Let's look at another example. We're going to start at negative 3 and go up 1 over 1. It's a dashed line because it's just less than. Again, we can pick a test point of 0, 0, put 0 in for x, 0 in for y, and solve. Is 0 less than negative 3? This is false, so we don't want to shade where 0, 0 is. Our second equation, we're going to start at positive 2 and go up 1 over 1. It's a solid line because it's greater than or equal to. If we pick a test point of 0, 0, put 0 in for x and 0 in for y and solve, and we have 0 is greater than or equal to 2. This is false, so we're going to shade above the line. Now, we can see these shadings. If it lands in just the orange shading, then it does satisfy equation number 1. If it lands in just the blue shading, it does satisfy equation number 2. To get a solution here, we do not have any place where the two lines cross, so we actually don't have a both. We actually just have a neither here, which is this middle section where no shading crosses. So just like before when we had parallel lines, on this one we're going to have no solution because the shadings and the lines never cross. Now, if we took these inequalities and flipped them from what they were before, so instead of a less than, it's a greater than, and instead of a less than or equal to, it's a greater than or equal to, then we can see that the situation would be a little different. Our shadings would flip-flop. Instead of going out, they would both go in. So actually we would have a solution here. For just number 1, we would be up here in just the orange section. For just number 2, we would be down here in the blue section. And then we actually have a both here where both shadings are crossing in the middle. This would be our solution. So just because two lines are parallel does not mean that we don't have a no solution anymore. Alright, so when we're determining solutions, make sure your shading is correct, because if your shading is not correct, then these lines and solutions are going to be completely wrong. Pay attention to where the shadings cross. This is the true solution. It's no longer just where the lines are, but it's where the shading is. Sometimes there is no solution. If the shadings never cross, no solution. Even if the lines don't cross, you can still have a solution like we just saw in that last one. So please make sure you're looking at the shading and where the shadings cross, not where the lines cross. Don't forget to take notes as you go. Take the survey now so you don't forget. Bring your questions to class tomorrow, and make sure you know how to graph a linear inequality, because we will be doing a lot of these tomorrow. See you tomorrow.